Hello, everybody. Welcome to Digital Ship webinar on smart voyages, how to generate faster insights with historical weather data. Our guest speakers are steady and ready here with us. Let me welcome them. Chris Manzeck, he's a sales engineer at Spire. Tom Bebbington, Maritime Innovation Specialist. Also here with us is Simon van den Dries, Vice President of Business Development with Spire. And finally, Soren Meyer, Chief Executive Officer at ZeroNorth. We expect your questions, of course. Please type them to a Q&A box anytime throughout the webinar. As we know, weather impacts maritime operations quite a lot, and I invite Carl Jeffrey, founding editor of Digital Ship, to tell us more.
Okay, so our theme is historical weather data. So I'll just make sure everybody understands what historical weather data is. So a weather forecast is when you get told what the weather is going to be like up to, say, 10 days into the future. And historical weather data is what you might use if you want to see, for example, what the weather is going to be like on a holiday you're planning in 6 months' time in Greece. So it's based on an average of the past 20 years, and it's getting more and more available to us on consumer websites. You can normally tell if it's historical data or weather forecast, because the weather forecast is only a few days in advance. Now, historical weather data is particularly useful about now because we might have started recording detailed weather data, say 20 years ago, and then if we get an average of the past 20 years, that's the sort of data that's useful in making forecasts. So if a shipping company is planning a route for a voyage of more than 10 days, so something we do quite a lot, then after the 10 days, you can use historical weather data more than using the weather forecast. And there's a lot more that we can maybe do with historical weather data, which companies are starting to think about. For example, if the history says that when the weather gets to a certain temperature, there's more fishing vessels in the water, or when the weather is in a certain condition, we've had a lot more accidents. There's good things for shipping companies to know in a whole new world. So we've got 4 great speakers today, and we're going into depth into this topic, and they're all speaking without slides, so great engagement. We're going to go to Singapore, Denmark, Wisconsin, and then Luxembourg. So first we're going to Singapore to hear from Tom Bebbington, who's a former navigation officer on container ships. Now he works as an independent advisor to startup companies in the insurance sector, and he's going to talk about what container shipping companies in particular can do with historical weather data. Second, we're going to Soren Meyer, who's the CEO of ZeroNorth in Copenhagen. He'll talk about how his company uses historical weather data as part of voyage optimization. ZeroNorth is a company that helps the shipping industry optimize operations with digitalisation. It's a spin-off from Maersk Tankers, and they're also supported by Cargill. Third, we're going all the way to Wisconsin, to the village of McFarland, and hear from Chris Manzeck, who's a meteorologist and sales engineer at Spire, which is sponsoring today. Spire is a specialist in data and analytics for the planet. And Chris is going to explain how we can make it easier to use historical data, in particular, reducing these enormous data sets into something useful and actionable. And finally, we're going to go to Luxembourg and hear from Simon van Dries, Vice President of Business Development at Spire, with some ideas about how to get value from historical weather data. So we should have initial presentations about 30 minutes and plenty of time for questions. You can put your questions in the Q&A box at any time. And if you want to say who the question is for, maybe they'll be able to answer it by typing while the other talks are going on. So I'd like to invite Tom to give the opening talk. Thank you.
Well, thank you very much, Carl. Yeah, so as Carl mentioned, I'm a former navigating officer, so weather is something that I've been using a lot. I mean, it would, using historical and forecast weather data, it's fundamental. It's a fundamental aspect of operating ships. It always has been. But it's also fair to say that reducing fuel consumption, especially in the line of work that I've been in, isn't anything new either. And but it's it's not with the goal of reducing emissions. It's usually the goal of reducing costs. And historical weather data in that context, it can be used to fantastic advantage when it's done well. For example, it's very common practice when heading out from places like Asia to the US West Coast to sail up the southern coast of Japan, use the Kuroshio current to push your vessel along, reduce the fuel consumption, and maintain your vessel schedule. The historical, as Carl mentioned in the beginning, anything more than about 10 days out, forecast data is not really that useful. So historical weather data is also used very, very heavily at a global network level. So when I say global network level, I'm talking about designing what does my network look like for the next 12 months. And by using historical weather data, shipping lines can more accurately calculate the realistic sailing times and schedules for different seasons. So, for example, the weather in the North Atlantic in winter and summer is very, very different. So, looking specifically at the container shipping industry, where you've got fuel costs ranging anything from 50,000 to 200,000 per vessel per day, depending on the vessel type and the speed you're going at. This is a massive cost. So access to historical and forecast data really helps make optimal decisions regarding the speed, the voyage planning, and the safety, both at a high level network planning view, as well as a day-to-day vessel operation view, whether that be onshore in, say, fleet operation centers, or actually on board the vessels themselves. Now, as container lines, the product they're basically selling is on-time delivery. They always have to find this balance between schedule, fuel consumption, and safety. And weather plays a huge contributing factor to figuring out where that balance lies. But weather data is a bit of a double-edged sword. When it's used well, we can save money, we can keep ships on time. When it's interpreted wrongly or just not used at all, it can lead to some fairly spectacular failures. And we basically live in an era where good enough weather data just isn't good enough anymore. As an industry, we definitely can and should be doing better than we are right now. And a really good example of this would be the one Apus, so 14,000 TEU container ship. And at the end of last year, she sailed again up the Japanese coast, catch Kuroshio Current. She would have had historical weather data, and she would have been getting pretty accurate weather forecasts as far as I know. She headed out in the North Pacific, but she managed to sail a little bit too close to a developing depression. And the end result was over 1,800 containers lost over the side into the North Pacific. Another over 3,000 boxes remaining on board that were either damaged or completely destroyed, and an insurance bill of $300 million and counting. But weather also has potential major implications for global supply chains. Another example here would be, say, cyclone season here in Asia. It can and it does lead to closures of the major ports, so places like Shanghai, Ningbo, Hong Kong, and any delays in these key ports then flows all the way down to Southeast Asia. So here in Singapore and the major transshipment hubs that we have here, I'm literally pointing over there in Malaysia, Tanjung Peluh Pass. And when this happens, shipping lines, they have to make a choice. You either leave cargo behind, and try and maintain your current schedules as best you can, or you speed up the vessels to try and catch up with the schedule that you originally sold. But of course, that's going to increase your fuel consumption. It's going to increase your CO2 emissions. So going back to historical weather data, this can be factored into your overall plan that you do once a year. If you take the last 20 years worth of data, you can look at when are the cyclone or typhoon seasons, depending on which part of the world you are. What are the historical number of cyclones? When do they hit? Where do they hit? And you can sort of build that buffer into the product you're selling to a shipper. So for a shipping company, what you're effectively doing is you're reducing the times where you have to speed up ships, spend more money, or leave cargo behind. And from a shipper point of view, you're providing a more predictable and reliable product. So, access to historical and forecast weather data is one element of what the industry could use to much better advantage than it does right now in terms of safety, schedule reliability. But that's just one part of a much larger picture. The focus very much at the moment is on reducing the carbon footprint of absolutely everything we buy, use, consume. And it's something that we as a shipping industry, we can't ignore this anymore. But despite this, the size of the industry, it has been something that's been relatively hidden up until this point. from the general public, but that's changing. However, I won't wander too far into that topic because that's in terms of what the industry is doing to address that one. Because I'm going to hand over to Soren from ZeroNorth because he has far more expertise than me on this one. So yeah, that's over to you, Soren.
Well, okay, so we're going to Soren Meyer from ZeroNorth in Copenhagen, which is a vessel performance company, which is a spin-off from Maersk Tankers.
Yeah, so I think it was a little bit big words of saying that I'm a more expert here and so on, but I would definitely like to give a perspective of this, right? So in ZeroNorth, what we are really focusing on is keep on embedding and empowering the industry to take better decisions in order to optimize. And in order to do that, we need to collect and put a lot of different data points together, which including the weather. But it's not, of course, it's combining the weather data and historical weather data to the fuel performance models of the vessels, with the market, with the bunker prices, with the rules of the ocean, to kind of make that into a full optimization engine for that part of it. I think we have to remember that every time that we are going into the optimization challenge and looking ahead, it's about simulating. And when you're simulating, you are building simulation models. And one of the most important simulation models that is out there is actually the underlying fuel models. So what we have done in ZeroNorth after partnering up with other Danish company that we acquired here in the summer called Propulsion Dynamics, which is now integrated into ZeroNorth, is really having a global database of more than 25,000 ships models and having like what is the consumption in any type of weather. And I think what we do with the historical weather is very much also training those models and improving the models using the historical weather data set. So by having good historical weather, you are able to keep on training your models, and thereby, because you know that what actually really happened, you can begin to go back and say, okay, what if I didn't know it? And what was the forecast? And then you'll model that, and then you can measure it up against the real weather. So there's a lot of like underlying value in really strong historical weather that you're using to calibrate and build your simulations. And then rightfully said, of course, when you get further into the voyage optimization more than the 5 to 7 days, then you're also beginning to see that the weather forecasting is extremely difficult. And there, the best forecast is the historical weather data. So that's where we use it again to say, okay, we have the underlying fuel modeling, we know what is out there going forward, and then we keep on monitoring so that you can actually do your route and your weather optimization at a constant, right? And that's what we released here last week in ZeroNorth, is a real-time weather route optimizer. So taking the sophisticated fuel models of all the vessels and then train the models and embed that into any vessel so that weather routing is not something you ask on a per demand or when you think that you need it, but weather routing using data here is something you have at your fingertips at any given point. Because the weather routing is not only, it's of course about safety, but it's about having the triangle between safety, emissions, and US dollar. And you want that at any point, and not just when you think that you're sailing into bad weather. So I think that's really where the whole historical weather aspect comes in. Of course, the industry is also well known for being fairly siloed between the different players, from charter party to operator, for cargo owners to operators to vessel owners. And there's especially between the vessel owner and the charters. So the operator, there's often a time charter model where you have a wanted speed. And we do see around 10 to 15% of all voyages where that ends up in a speed claim. And there you have to go then back in your historical weather and say, okay, what actually happened? And people will fight about like who was right and wrong and what's actually the weather, because most of the wanted speed clauses are saying something about that it's only in good weather. You say our vision in ZeroNorth of how to use this data set and how to look forward is how do we actually get a combined understanding on what's happening in the oceans to a high enough degree of accuracy so we can have people sitting on the same side of the table optimizing together instead of spending time claiming each other and try to sub-optimize. And I think that's really the big hurdle that we need to come across, is having like people trust the data that is there, so that people are not arguing if the data is accurate or not, but beginning to work together towards how do we optimize on all parts of the silos, and that we collaborate, and that we have a common way of splitting those benefits. And that comes back to the whole accuracy of predicting, of measuring, and that's where, again, one of the most vital parts of the data set is the historical data. So I think we are on a super interesting learning curve, and the data is coming into a much higher degree of accuracy, and that just keeps on spiraling all of the opportunities. So when we are talking about voyage and vessel optimization, it's not that the industry is suddenly saying, wow, okay, fuels are more expensive. Fuel has always been a big cost element. But we are now just getting that's much more data, so we can begin to do the modeling, and we can begin to build software that we can embed into the daily operations, and don't have to have in a black box with experts. Like, we want to have these tools with those that can take the decisions. We want them at the fingertips. You don't need to be an expert in order to do weather safe routing and optimize. You want that to be embedded in the products that you have right in front of you. So that's what we are really focusing on in the ZeroNorth side of going there. And why is it that we need to optimize now? Why is it we need to embed that? I think everybody can agree that right now the industry is still focusing very much of the US dollar, and perhaps actually on a day-to-day basis, much less about the CO2 emissions. Because, well, the industry is fueled by US dollars. So we talk a lot about emissions. We talk about 2030 and 2040 and what we need to do for the future. But we need to begin to more transparency around what's the impact we can do now on emissions. And if you see some of the sectors that's making a lot of money right now, they are all speeding up, right? And that's not good for the emissions. So we also need to have this data set to say, okay, by us doing the behavior we're doing, what's actually the impact on the CO2 emissions? And one of the big changes that will come, of course, is the CII rating of the vessels that we'll see at the end of next year. And people are really beginning to look very much at that, because it's highlighting the difference between the different silos. Because again, it is the ship owner that will be hurting on the CII rating, but it is the charter that is setting the speed. So again, we need the historical data to train model to say, okay, when you take these decisions and you need to embed that into your real-time weather router, you need to say, okay, if I actually do this speed and this route, what is the impact of my emissions? And then you say, okay, but I actually don't want to have a go down in rating, because then my time charter cost will go up. So what route and what speed do I do now, right? But all of that lingers that we have more and more strong data sets to do those simulations. So super exciting, and we need to reduce the fuel bill now, because that is actually the one that will spark and make it cheaper to transition to the new clean fuel for the future. So we need to act now, and the tools and the data is available, and we just need to begin to use them.
Wow, that's great. We'll take questions at the end, but I thought I've got some interesting questions here. Maybe I'll just draw people's attention to them so we can sort of thinking about them. So Dougal Goodman, I think, is from the Foundation for Science and Technology in London. So he's asking, what do you do about the El Nino years? So I guess that's years when you have particularly hurricane or turbulence weather. And he's also asking about where the wave height historical data sets come from, even if the waves came from a long way from the vessel is now. And then Joseph Sajan, whose LinkedIn page says he's with SGN and he's on a mission to help the maritime industry meet its emission targets in Oslo, but he's asking a fairly simple question: is 2 years or 5 years good for historical data? So I guess the summary of all of this is you really know how to do with this, how to work with this, I suppose. But we're going to Wisconsin now. So Chris Manzeck is a meteorologist and sales engineer. So I'd like to invite Chris to give the talk. Cheers.
All right, thanks, Carl. I appreciate it. So that's a good question regarding how much data is required in order to attack some of these different weather-related use cases, and it really is use case dependent. So when you're talking about things like El Nino and La Nina years, right? You have different oceanic current and sea surface temperature patterns that emerge as a result of that, and also different larger scale weather systems that can be more or less active in certain regions. So for analyzing that kind of an impact on, what is this year or this winter going to look like from a weather forecast perspective, you really do need more, I would even argue, than 5 years of data. You want to analyze a longer term, more of a climatological trend, if you will. So looking out 10, 20, even perhaps 30 years into the past in order to see, in the past when these anomalies were here, how much was that weather different above baseline, in a certain region. So there's a lot of information that would have to be analyzed to get at that kind of information, or to look at those types of insights when it comes to La Nina, El Nino, and as I said, the different weather patterns that emerge as a result of that. And of course, it's not an exact science, right? And the reason we're here today talking about historical weather data is because, forecasting weather, although we do pride ourselves at Spire of doing an excellent job of this in the middle of the ocean, weather forecasts still have their limitations. You simply cannot forecast with much degree of confidence beyond the 10-day or maybe the 15-day time window. Once you get beyond that, the inherent differences in the different forecast models and how the atmosphere simply behaves as we experience it here at the surface of the Earth is just too difficult to understand or to analyze at an accurate level. Right? We can produce a forecast that will go out 50 or 100 days, but it would be worthless data because it would be so vastly different when that time actually occurred. And it would cost a lot of money to run a forecast model out that far as well. So at Spire, from a historical weather data standpoint, and what I've noticed in the industry is that, and this comes from, so my background is in meteorology, and I've worked in the business-to-business sector of weather, so selling weather data and helping businesses take advantage of weather data across many different industries in my career. So the maritime industry, while it's relatively new to me, I've been here for about a year now at Spire, I see it having a very similar trajectory to the usage of weather data as the over-the-road trucking or shipping and logistics industry did on land, which I had a lot of experience with in my previous role. And that is typically slower in the digital transformation space, right? So lagging a little bit behind potentially other sectors, especially as compared to like airspace. And therefore, a lack of adoption of usage of external data sets to help you make smart decisions when it comes to moving your goods around the surface of the Earth, whether it's on land or on the water. So I see a lot of parallels between the over the land shipping industry as well as the maritime industry as we know it right now. So I joined Spire because we have this unique, rich data set of weather, and again, a lot of it is around forecasting, but we have a lot of innovative things happening on the weather historical side of the house as well. And so for history, one of the difficult things of weather data, when you're talking, a company like ZeroNorth is sophisticated enough to use these massive data sets, but weather by itself, much like fuel consumption and optimizing of shipping routes, it's a big data problem. So weather on its own is a huge data set. And we're talking on the order of several gigabytes of data for a single hour of what's the current weather state of the atmosphere, like at the surface of the Earth, just for oceanic data. Right, so you're thinking about all the different types of waves, whether it's wind waves or swell waves, the direction, the period, the height. Then you also have surface wind forecasts and sea surface temperature data, temperature, precipitation, right? When you mesh all those data sets together, you have this massive amount of data, which, while helpful at the surface because you have all this data curated, and that's part of what Spire brings to the table, is like we gather this data from many different sources and make it really a lot easier to consume in mass. You still have a huge data problem. So, while on one hand we can help by providing companies with this large gridded data set, again, several gigabytes, if not terabytes, by the time you look at data over a large oceanic basin over the past 10 years, we have hourly weather data, right? So every single hour you're getting what is the current state of the surface of the ocean and the near surface atmospheric properties. So it's a huge amount of data to work with, which, again, that by itself can be useful if you're a very sophisticated company with tons of compute power and lots of storage space and the ability to parse through all that information. But what we quickly realized as we were talking to more and more maritime clients in this space is like, look, this is valuable data, but how can I get anything out of this, right? It's good to have the data here. That's like step one, just get it in my house, in my building. But then how do I extract value from that? And one of the easiest ways we saw that we could help the industry from that standpoint at Spire was, hey, what if we built a tool that sat on top of this historical data that allowed users to extract based on known ship locations and timestamps, and just extract only the little bits of data out of the data set, out of the grid, that would allow you to take the several gigabytes or several terabyte set of files and narrow them down into just a very few, CSV files or JSON files, something that are really easy to parse and understand from a file format perspective, but are also tiny, tiny, tiny files as compared to this massive gridded historical data set. So we're super excited to bring that to the industry and just essentially enable all these different use cases we've heard about today. And again, I'm not an expert in the maritime industry at this point in time, but looking at the emissions, the insurance use cases, and so what happened to the ship? How can I project beyond 10 days in the shipping lane, how the weather is going to be? Solving all those basic problems of finding the path of a vessel, either historically or in the future, and what it's likely to encounter from a weather perspective is something that we think this historical weather data by trajectory product that we've brought to market is really going to help enable all those use cases across the board. So we're doing that for historical weather today. Again, that's bringing in multiple different data sets, ocean currents, ocean winds, sea surface temperature, all of the critical components you would need to build these emissions models and these fuel efficiency models, etc. And then, some of our short-term roadmap items include also the ability to do this, but for our near-term forecast product as well. So being able to look at the 10-day forecast, and again, not consuming that in a large gridded format, that's typically a little bit more difficult to wrangle with, but allowing you to insert positional data, GPS data, along with a timestamp, and then get that exact weather forecast out for your projected vessel route. So at this point, I'm going to hand it over, I think, to Simon at Spire to talk a little bit more about what we're doing in the maritime space as well. So happy to stick around for questions, but Simon, over to you.
Yeah, thank you, Chris. I think when we see customers coming to us to buy live weather data, most of them, and that is actually true for all of our data sets in Spire, most of them will buy the live data in combination with historical data. And that goes from at least, I would say, 2 years to now what we have available for more than 20 years of historical data. And that comes from different kind of values that we have that. And as Chris just mentioned, it's just a massive amount of data. People will use it to find their own algorithms. We try to make it as easy as possible to get access to these huge amounts of it. And I do believe that the technologies to digest and handle these large amounts of historical data sets and build your own algorithms on it is getting better. And we see things from that historical parts that we could never have imagined. We talked about with ZeroNorth the example of vessel performance, but we also have examples in the insurance company where people are putting certain risks related to weather patterns, to particularly hurricanes, but also to wave heights, and try to put a premium and a risk indication on certain routes based upon the historical part. We have people that are doing constructions at oceans, constructing windmill parks, constructing submarine fiber cable opticals. They're trying to find correlation between what's the change of sea surface temperature and fishing activities. And the moment that you have found that correlation, and you can see that sea surface temperature is actually going more north, you will then also see that fishing activities go more in that region. And that could be influencing your decision to construct a certain windmill park or a certain submarine cable optic. So these are just a few examples of using that historical weather data. And as I said before, most of them, they would start with building their algorithms based upon the historical part, and then apply it to your live data. Once you have the live data, it's very important that your historical data and your algorithms are based upon the same kind of resolution pattern than the live data. So it's very important that you put that synchronized in there, and that's what we facilitate in there. So I can see a lot of opportunities, and I think right now the industry is heading to more and more perfection. So just good enough is not enough anymore. It needs to become closer to perfection, and algorithms and historical data, historical weather data, brings us significantly closer to predicting with higher accuracy than ever before. So let's maybe take the questions from here, Carl.
Oh, yeah, that's fantastic. Yeah, no, it's very interesting. I think one thought that comes into my mind is that this could be quite dangerous if people confuse historical weather data with the forecast. I think just because the history says it doesn't rain on October the 5th doesn't mean it's not going to rain on October the 5th next year. But yeah, well, if we start with Google's question. So as a meteorologist, I guess this goes to Chris and Simon. So I don't know what persistence year on year means, if he means we're sort of building up a knowledge base, or we know what El Nino comes every 7 years, or do you want to start with that one? I don't know which view is best to go for it.
Yeah, so yeah, it's interesting. I mean, you have a couple of different ways to attack this, right? You have you can just look at a long-term historical record and see, you know, on these types of years where there's El Nino or La Nina or where it's more neutral, you know, how does the weather pattern affect these particular, you know, vessel trajectories, these routes that I'm going to take? And that would probably be the place to start. Is like if you look at the El Nino years as accounted by climatology centers, and let's say there were 8 or 9 of them in the past 30 years, right? You'd analyze all 8 or 9 of those and look at what are the averages, and then you'd analyze that against the baseline in the same routes for non-El Nino years, and then look at the difference there, right? That would be the very first way to start analyzing some of that information. When it comes to like predicting how that's going to change in the future, right? We all know, I think, and understand that climate change is upon us and is causing things to perhaps change more rapidly than they had in the past, right? So you can fall into a bit of a pitfall of, like you said, like assuming that because it doesn't historically rain on October 5th doesn't mean it's not going to happen this time. So there may also be another element of wanting to look at some of the more recent history of when these events occurred in order to understand, you know, is there a trajectory there of something shifting, right? Are the currents in this area shifting more dramatically in the past 5 years than they have in the previous 20? And that can certainly happen in different parts of the world. So again, lots of different ways to attack that, but it really depends on, you know, sort of how granular you want to get, I think, in answering that question.
Oh, should we go to Joseph Sajan's question about how much history do we need? Is there an optimal answer? I suppose the more history, the better, I suppose. Is it?
Yeah, I mean, when you're talking about historical weather data, I think the conventional wisdom when you're talking about predictive analytics, you know, in general, is going to be about 3 years of data. And that's going to be good enough for some of the entry-level use cases. But as I mentioned, when you look at things like climate change and how things are evolving, with respect to that, and how's that going to affect certain, you know, shipping lanes that have more or less traffic in them, or are they shifting south or north subtly? You know, then you'd want to analyze additional data beyond year 3, probably at least to year 10, and all the way back to 30 if you want to get that full historical record.
Well, maybe go back to Soren, because I'm fascinated by this modeling, how you build this as part of a model, because you've got I guess it's probabilistic. You're saying, well, we know this is most likely option, but you can't guarantee that a vessel's going to arrive at a certain time still, can you? So I guess it's quite tricky to get this balance right. Is that between probability and forecast? Or?
And that's why you keep on having to optimize along the journey and the voyage on itself, and that is not something you do on on a daily basis when you have like a standard process to do it once a day. This is why you have an algorithm that is running at least one every hour and keeps on looking for like where is a vessel actually doing what you expected and what has changed, right? And then you keep on running that as an ongoing prediction. So I think that's again where we need to make any weather routing optimization. We need to turn that away from being a black box to really being something that's at the fingertips and super transparent to the users, and especially the operators at shore, because they are the one actually sitting with the gas handle and being able to instruct the vessel. With the super high respect that we of course need to listen and protect the seafarers and the cargo on board from a safety angle. We just need to make sure that that comes in a triangle, but also making sure that we make the most money in the most energy efficient way.
Yeah. And how would you map this as part of the whole vessel performance subject? Because it's an enormous subject and there's lots of different methods that all give sort of 1-2% improvement. I suppose this is another one. We're talking about 1-2% performance optimization from good use of historical weather data. Is that a useful way to think about it?
Yeah, no, at least I would like to claim that it's probably more, right? So as I said, we just released the real-time weather route optimization last week, but we do see quite a big uptick. you're asking how does it fit together? And in ZeroNorth, the way it fits together is it's one common database, one common tech stack, where you have all the data and you have all the vessels and you're simulating in all different. And from there, you can build multiple different products. It can be building a product of where, when, and how much to bunker. It can be a product around how do you get most optimal from A to B from a weather optimization perspective. It can be monitoring the fuel consumption of the vessel. Is the hull performing? Do you need to do a propeller cleaning? Are you using too much consumption on the accelerating engine and so on, right? And then you say, but okay, remind me, how is historical weather coming into this? Yeah, because you need to be able, when you do modeling, you need to go back and being able to say, okay, I'm now standing 12 months back and I'm simulating what would my algorithm tell me to do. And then you will take and you'll do an A/B testing, right? So you have a certain part of your data that you are excluding from that. So when you are running it, you can actually see you have a proper data that you can rerun and saying, okay, I don't cheat, right? And I think there's a lot of discipline around how do you building modeling and how do you simulating, and that's where you need the historical data, but you need the historical data in a format where you can use this for this modeling. And I think sometimes we are forgetting how the industry is super unorganized around data and data quality, right? So it's about finding partners that has a common understanding of how important is that data is in a structured format and that it is being cleaned and that it's in a usable format, right? So I think those are the data partners that are coming in, because one party cannot solve the problems for the entire industry.
Oh, that's fantastic. I think you're representing the customer here, the person who has to use all this stuff and get value or not. I think so. It's a great have your perspective. There's a lot of technical questions coming in, but I'm worried about leaving Tom out of the discussion. So maybe a question for Tom. As a sort of former seafarer, I mean, what do you think the seafarer perspective is on this? Because you've got to really understand whether it's a forecast or whether it's historical weather data and how much to lean on it, haven't you? There's a lot of
I think Soren hit on a really good point there. I mean, it's all great having this data, but if it is just a black box and the data is going in there and it's spitting out an answer, and I don't understand how I got that, that's when you run into problems. I mean, there have been so many cases over the years where there have been incidents, cargo lost, ships running aground, and so on. And when you actually sort of dive into the actual accident investigations, it's the answer has often come out. The weather routing software told me. Yeah, but it's got to come with a bit of common sense, and you can't. Yeah, and I think as well, what we're seeing now is, certainly when I was at sea, basically captain was in charge, and that was that. But now you're seeing more and more. You have fleet operations centers that are literally watching the vessels every hour, every single day. They're making decisions, and these are not seafarers. So you do need to be able to take that weather data and be able to present it in a way that is both understandable to someone on a ship, but someone who has no experience of being on the ship as well. Because it's something that when you look at weather, and from a shore-based perspective, it says, okay, based on the historical data, it's absolutely fine to go on this route at this time of year. Captain will come back and go, no. Based on what I know, not workable. So I think really it is that key to having the data, making it understandable and usable. But you've still, I mean, again, as Soren mentioned, you have to tackle this massive problem within the industry that when it comes to digitalization and data, it's literally all over the place. I think I usually describe shipping as, on a good day, it's about 20 years behind the rest of the world from a technology point of view. I've been in companies where, on a good day would be 40 years behind. So it's something that they all know they have this data, but what they don't know is, what do I do with it all? How do I get this all together? And I think ultimately, it's always the answer to this is always going to be outside companies. So companies like Spire, like ZeroNorth, actually providing data services to shipping companies, because in the nicest possible way, I honestly don't think they're capable of doing it themselves.
Oh, we go to the questions here. So I think just about every question is talking about data quality in some way or another. Maybe the top three, we could start with Simon and Chris. So So Leonard Sederberg is actually a marine meteorologist. I don't really know how historical weather data can be accurate, since it's history. It's not about the future, but he presumably knows what he means. So maybe you have some thoughts on that. Dougal Goodman is asking about the wave heights, if they came from a long way from the vessel is, and then he's also asking about what if the processes for collecting the data has changed in the last 10 years. So I don't know, Chris and Simon, do you want to have any thoughts on those?
Go ahead, Chris, on that side.
You're on mute at the moment. Is he lost his connection? Oh no.
Sorry, my child walked into the room, so I was trying to get him to leave. He's not, but he's going to stick around. So, I mean, on the topic of data quality and sort of like having confidence around sort of what it is that we're providing, right? I think it's fair to say that it's impossible to observe the current state of the ocean like everywhere at all times, right? There simply are not an unlimited number of data points that are helping us to gather this information. Spire is filling in the gaps in the upper levels of the atmosphere. So one of our key differentiators as a business is we're observing through our nanosatellite constellation the upper level wind speed data, pressure data, temperature data, which affects everything that happens at the surface of the Earth, right? So we have this immense amount of coverage over the middle of the oceans that simply isn't observed or measured by any other instrumentation that's out there today. So that is a huge advantage for us, just in terms of having at least some data in the middle of the oceans. Granted, we don't have buoys every 3 nautical miles on a grid to help you observe the period and the wave height and all that. But we can do our best and approximate what the surface is going to react to and how it's going to evolve with that additional data set that comes sort of from right above the surface.
That includes the wave height, so that answers Dougal Goodman's, or at least the wind.
That's right.
Yeah.
Yeah, and I mean, and it's fair, right? Things are affected by waves. Waves can come from, of course, a very far away weather system. But that's all, when you're modeling the entire world, you're aware of that, right? So we know that a tropical cyclone or a hurricane has formed in this region, and it's going to propagate and send large waves with swell far away from that. And as your model knows and keeps track of that, you can forecast and look at when is that going to impact my route, either historically or in the next 10 days.
Yeah, maybe to add on that, as Chris said, I mean, due to the fact that we have our own weather observations, Spire weather is particularly accurate in open oceans. That's really where our strength is. But it remains models, and certain models behave slightly different than in others. I would like to highlight maybe one other customer of using Spire weather data. It's a New Zealand company called Predict Wind that is actually predicting the wind for maritime parts. And they do have a model validation tool recently launched. And you can see in certain regions, going back in the history, how a certain model performed versus another model. And you can see that in certain regions, different models have different parts of it. So in general, I would say Spire scores very high on open ocean particularly, and that is only going to increase going forward. But if you look back at the history, it makes sense as well to look and compare how did certain models behave in certain regions over time. And that's a very powerful tool as well to take into account.
Wow. And then Dougal's question is asking about what do you call rare events, which might not happen in the last 10 years, but insurance industry says, well, this is something that may happen once every 50 years, and we've got to put in a chance of that. But maybe we're not talking about hurricanes here. We're just talking about changes in the wind, so we don't need to talk about rare events. So is that for Chris or Simon?
I think maybe I can chip in a little bit on that one. Certainly when it comes to insurance and cargo loss, cargo claims, and so on, almost the very first thing you hear out of a shipping line is rogue wave, and you're like, come on, it's and this is where the insurance industry, it does, when incidents do happen, one of the very first things they're doing is diving first of all into the historical weather data for that region. Did the ship know that it was going to be sailing through a region that is particularly prone to bad weather? But then secondly, they'll also be looking at, I suppose in this context, you would describe it as what was your historical forecast? So what I mean by that is, as the ship was sailing along, what was the forecast it was getting? what was it doing with that data, and then what decisions were being made based on that. I don't know how the insurance industry sort of really deals with things that are kind of what they consider low probability, because anything when it comes to insurance and the way, especially the way it's set up in the maritime industry, is what it all comes down to, and I guess this is true of all insurance companies, is how do I pin the blame on somebody else? And so weather is one very, very powerful tool that they can use to do that, both from a historical data point of view and a historical forecast point of view.
Oh, it's all very interesting, isn't it? So, nice comment from Owen Vatchell, who we think is from a Clearwater Dynamics project analyst. So he's saying we analysed 15 ships, compared the live pitch and roll data with the historical weather data, and the results were fantastic. We could verify the data from different geographic regions. But then he's saying, do you think there's a place for live data to improve weather models? I don't know, live data is weather happening right now. Well, I suppose that's kind of what the forecast does, isn't it? I guess combining a forecast with historical data is kind of what we've been talking about, but sorry, I'm mumbling. Is there anybody got any thoughts on?
I can so there is of course people out there that is experimenting of putting weather radars on the vessel, so you do get live data, right? And when it comes to performance and get that super accurate down to the vessel, I think that is it can be very interesting, especially if you then combine it with the forecasting and the historical data, right? So then you get like real-time weather data from the vessel that is super accurate, but you combine it with the other data sets, and then I think you're modeling, so you don't need like 30,000 vessels with that equipment, right? But if you get a certain amount, then you will be able to use that to go down to the different level and in your modeling. But of course, it's also when it comes down to some of the examples that Thomas mentioned on insurance and claims, then of course that kind of data set it could be good in order to claim each other or to avoid an insurance case, right? But we need to get to a stage where we're not claiming or trying to blame each other, because that's not an optimization. That's just passing on the bill to somebody else. And if we are to solve the CO2 challenge of the industry, we need the industry to collaborate across, and we need them to trust the data. And there we cannot rely on just having each vessel having a super accurate sensor data, each vessel having weather data. I don't think that is not the golden key for this. The golden key for this is big data that is aggregated, and that will actually give you a much stronger prediction ability than just looking narrowly at my own isolated asset and have very accurate weather data or vessel performance data on that one. We need to aggregate it up, and we need to have a much wider data set, and really have this, call it more big data, but it is what we need in order to accelerate the industry.
Yeah, I mean, for Soren, I mean, one of the big challenges with CO2 is you've got both the prediction and the live, which are very different modeling challenges. One is making the best decision about the future, and one is saying, can I do better now? And I suppose from your point of view, making the software, they're completely different, aren't they? Because I guess you have to do both of them, isn't it? Or maybe you're more on the planning.
Both of them. I don't think it's a super big difference. I think it's a combination of the two that will make this powerful. But I don't think that will solve the problem. What I'm trying to say, by getting, if I have one vessel and I put all the sensors in the entire world, and I put a weather radar and I get all the data from that one vessel, that will never give me enough data to model what will actually happen for the rest. And it will not give you enough data for that one. Even I have a vast data set there, I think it's not deep enough, it's not wide enough data set to actually do any proper modeling. I think it will be nice to have a historical analytics, but it's not giving you any modeling capabilities to have that deep data set from one vessel.
Oh, well, that's amazing stuff. Just on this, for the Spire people, so combining live data, and so this is exactly what you're doing with your satellites, I imagine. If you're picking up live data about wind from satellite, you don't need to have a weather station on the ship, and you don't need the crew to be meteorologists. I guess you're doing it yourselves. Is that how it works, or is there quite a delay in getting data from satellite and modeling it? It's faster to do it on a ship, is that?
Sorry, with two of us on the call, sometimes we don't know who wants to speak first. So.
Chris, yes, you go ahead.
Yeah, so it's true. Like when better data in to any model is going to mean better data out, just like from a pure predictive modeling standpoint. And weather is not unique in that space, right? So you're right. One of the reasons that we're gathering data from our satellites and observing weather observations, sort of across the world, is so that we can improve our own weather forecasting models as well. So not just at the ship level, but on a global level. Like how much better can we forecast the wave height tomorrow or the sea surface temperature 5 days from now? So certainly anytime there's a new data set that is introduced into that, if it's of quality and it has enough coverage to have a wide-ranging impact on a global basis, then that data set could have some perceived value from a weather forecasting standpoint.
Oh, okay. And there's two questions from Lennart and Tim about validating historical data. I don't know quite how. I mean, historical data is not going to argue about it, but it doesn't mean it's the future. It just means it's the past. But I guess if someone's going to invest in it, they've got to know how useful it is. So is that something you think about and you're able to talk about?
Yeah, and this is usually done by comparing weather data to, I mentioned buoys before, kind of in jest, but like if you're going to observe weather data and actually observe it, right, like have a record, you have to have some sort of a ground truth. And so while they are sparse, that's generally speaking where you're going to be able to do any comparison between what our historical record was saying or what our forecast was saying for that matter, as compared to what actually happened on the surface. So we would look back and rely on those individual stations or those buoys that are observing the weather conditions and the wave heights, etc., in order to do that comparison and look at any sort of errors.
Oh, that's great. Yeah. So Tuna Senna, the last question is about I guess the same thing about wave monitoring systems in real time and feeding that into the modeling. I guess we kind of covered that it would be useful, but also we can do it by satellite and it's a lot simpler. I don't know. It seems to be a question a lot of people are interested in, this real time data and combining. I don't know if Simon and Chris, you want to have any thoughts on that one? You would.
Yeah, the last thing that I would say on that topic is that it's extremely complicated. In order to run your own global forecast model and have it be influenced by data sets that are not typically available in the weather forecasting sphere, I'll say, like traditionally speaking, there's data sets that are produced from national agencies like ECNWF, like NOAA, like UK Met Office, and others around the world, where they sort of hand you a starting point. And then you as a company, as a third-party company, can take that starting point, which is like the current state of the atmosphere, and you can run a model. It can be a regional model or a global model or whatever you want to do with it. But it actually is very difficult to take that starting point and layer in additional data sets that you have as a third party. It takes a lot of work and teams of people. So that's what we do, is like we have a huge team of people dedicated just to bringing in our satellite data and meshing it and merging it with those existing data sets to get a better starting point for the forecast model. So that's kind of how that system works. And yeah, we do introduce new data sets from time to time, whether it's from our satellites or other observations.
Oh, that's great. Well, we're getting to the last 7 minutes or so, and we don't have any more questions. I'd like to just give to Soren. I think you told me once how many data scientists you had. I can't remember. It was some enormous number, but I guess maybe that illustrates how hard it is getting value from this. You've got a lot of data processing at Spire, plus all your experts building models. But I suppose this is the way forward. If you have all these people validating and modeling and doing everything, you can make enormous value in it, and it's worth it, I suppose. Is that a sort of thought to leave our audience with, do you think?
No, I think both, at least at our side, we started last year, right? In ZeroNorth, we started in June, and there we started with being around 6-10 people, and now we are close to 70, and I think in Q1 we'll be around 100 people, and it is data scientists, software engineers, data engineers, and the type. Of course, we also have like salespeople and admin and so on, right? But around 60 to 70% of the people is data engineers and software engineers, and I think that is what you need to have a tech stack that can really be like a uniform tech stack that can build multiple different use cases across, right? So that is scalable and that is not a tech stack that I think is fairly, I would not say easy, nothing is easy, but if you build something for like one use case and you are narrowing that down and you are only building for, let's say, 5 or 10 customers, right? It's one thing. But if you are actually building for scale, and now what do we have? We have around 1,600 vessels using the software and keep on growing on that, right? then it's a totally different animal that you're having. The scalability, the uptime, the security, it is just a different skill set of building that in that, and you need to keep on iterating very fast on that. And I guess Spire will be echoing a lot around how important it is that you stay ahead here and that you keep evolving and use the latest technologies to enhance your offering.
Oh, that's fantastic. There's a couple of comments from Dougal. He's put in a link about a system to get an information for the whole ocean. That's a couple of years ago, and tools that insurance are doing over modeling. But I guess from Spire's perspective, if you've got this data from the whole world in one go, that's also gives you a good head start. We just got about 4 minutes left. I don't know, maybe as the sponsors, Simon and Chris, you'd like to take a couple of minutes each to give some thoughts you'd like to leave the audience with, or how?
Well, I think to the previous point, I think it's very important that we're going to have better roles for data engineers, data scientists in the maritime industry. If you are in the data analysis right now and you are just coming from university, would you go into aviation or in maritime or in agricultural or in climate? But I think those people, they will go in everyone. I think it's very important also for the maritime industry that we attract that we use the data into our best advantage. We need to have the smartest and the brightest people and the latest technologies available to really benefit from all the data that is available and the historical data and historical weather data in this particular case. So it's very important that we bring more attention to the opportunities that exist there, that we have the right people coming in, because actually the entire world is looking for good data scientists. And we need to make sure that the maritime industry, because we can always, I think, as Tom also said, on a good day, we would be 20 years behind. But on a positive side, I see a lot of good changes in there. Companies like ZeroNorth are really innovative here and really doing groundbreaking things. So yeah, I'm very confident about the future, and we have lots of opportunities ahead of us.
If I can add on a last note on that one, right? Because as Simon is saying, there's a lot of industry and software engineers, data scientists are in a fairly high demand for many places. That's where, like, yes, maybe shipping is behind. I think we're catching up super fast as an industry. Maybe the adoption then can go faster to that. But I think actually it's super easy to recruit for it, because the problem are so significant and people can get an impact, right? People can really make a difference here because it is such a big industry and with so big numbers, right? So when you are looking at an industry that is like 3% of the global pollution, and they can see that they can be part of actually like optimizing that and the money involved, I can find it the story of turning global trade green is just an attractive story for candidates. They want to do a difference. They just don't want to do coding and work. They want to be part of doing a difference. So we can be very, very proud of the industry, of the ability to attract talent in that respect.
Well, you're the hottest employer in Copenhagen. Yeah. Well.
Oh.
Wow.
Yes, of course we are.
Well done. Yeah. Chris, do you want to have a last word before we...
Yeah, I guess that Simon captured a lot of it from Spire's perspective. I would just say that we're here to help. We're keen to be a big player in the maritime weather space, and we're gonna keep pushing the envelope forward. So yeah, just looking forward to seeing what we can do in the next 5 to 10 years.
Wow. And Tom, do you want to take a half a minute or something?
Yeah, I mean that's been great, and I think Soren hit the nail right on the head. It's the industry. It hasn't got the best track record in terms of where it is technologically, but it is catching up and it is realizing this. And I think it's great that companies like ZeroNorth, Spire are getting involved in this space, because it is a massive space and it needs dragging into this century. So I definitely see positive changes, and it's been really interesting to do this tonight.
Oh, that's great. That's a very optimistic word from Soren. That's the first time I've heard of maritime industry being a great employer, and I guess that's what we need, is people building all these models and working all this stuff out and coming up with great solutions. So thanks everyone. I shall pass back to Vida for closing words. Cheers.
Thank you, Carl. Also, thanks to our speakers, also Spire Weather for sponsoring this webinar. Next week, I invite you all to join our webinars on Tuesday and Thursday. Sign up at webinars.thedigitalship.com. You may also review all our previous webinars on the YouTube channel. Goodbye. Take care.
Bye-bye.
Thank you.